Check this out. Here we go. We said that there is a limit, right? We said that there is a limit. But normally, a white dwarf doesn't have to worry about the limit because it's locked into a certain mass. In order for a white dwarf to possibly have a problem with the limit, something else nearby would have to be giving it a lot of mass. But normally white dwarfs are not in that situation. What's something that could be nearby to a white dwarf that would be able to give it enough mass to have a problem with the limit? What could be nearby? Here's a hint. Planets aren't big enough to contribute much mass to a white dwarf. Planets, I mean, you could have a planet nearby that would give it mass, but a planet has such a small amount of mass, it's not going to really cause problems. There you go. Stars. Stars. If there is another star really close to that star, to that white dwarf, it could potentially have a problem. So the only white dwarfs that have a problem with the limit are ones that are orbiting other stars. Okay? Do you guys remember what those are called? If you watched the videos last week, I talked about them. What is it called when you have two stars orbiting each other? And actually, the one that I showed you earlier, this picture is actually two stars orbiting each other. This is a regular star orbiting a white dwarf, and vice versa. They're orbiting each other. This is called a binary, right? This is called a binary. Watch a couple videos ago to learn more about binaries. I think I mentioned that. Maybe I didn't. Did I mention binaries? Either way, I'll say it right now. All a binary is a set of two stars orbiting around each other. Okay? It's a set of two stars orbiting around each other. It's okay. I'm sorry about that. Yeah, I guess I forgot that I didn't mention it. That's okay. So two stars orbiting each other are called a binary, okay? And if one of those stars dies and becomes a white dwarf, then you would have a regular star orbiting a white dwarf. And in that case, something weird can happen. If those stars orbit each other really, 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 really close, the white dwarf could actually pull on the other star. So check this out. Now, normally, we think of stars as being shaped like balls. But if there's a white dwarf really close to it, because they're orbiting each other, what could happen is it could cause the outer surface of this star to get pulled towards the white dwarf. And it'll stretch this star into a kind of teardrop shape. Okay? A teardrop shape. And if the white dwarf pulls just hard enough, some of this material could go towards the white dwarf. And it seems like it would end up falling right onto the white dwarf. But is that white dwarf sitting still? Based on what I just said about binaries, is that white dwarf just sitting still waiting for the stuff to fall on it? No, they're orbiting each other, right? They're orbiting each other. So by the time this stuff gets over to the white dwarf would have moved out of the way a little bit. And so what ends up happening is that this material ends up orbiting around the white dwarf. Here's a nice picture. I'll just show you the picture from the book, okay? Here's a picture of what I'm trying to show you guys. So here, this is a regular star getting pinched by a white dwarf. There'd be a white dwarf like right in the middle of this area right here. And this material is ending up orbiting around the white dwarf. Now that kind of looks like something we see on planets. What does this kind of look like on planets that we saw when we talked about planets? Rings. And it looks a lot like rings. The only difference is that this is a smooth disk made out of gas instead of small solid particles like in the rings of the planets. But it works basically like rings, but just made out of gas, okay? And so what that's called, that disk of gas, is called an accretion disk. Accretion disk. Now, I'm going to go ahead and guess that you guys have probably not used the word accretion. Somebody's asking, would it be like solar rings? It's you could kind of think of it as a stellar ring. Just remember that it's made out of gas, though. Now, like I said, I'm probably guessing you guys don't usually use the word accretion. So what does that mean? Well, it's the exact opposite of another word you probably have heard, okay? Like you haven't heard accrete, but you probably have heard secrete, right? Like if I'm giving off if I have a lot of secretions, that sounds grosser than I was hoping. What's happening? Like if I got a lot of secretions in my nosal region, what am I doing? Nosal region, that's the technical term for around the nose. I'm just kidding. Take an anatomy class. If I'm secreting, I'm giving off material, right? In this case, snot of some sort, right? Snot and tears. I'm secreting stuff, okay? Yeah. Now, so if a secretion is when you give off material, what is an accretion? What does an accretion mean? Like I said, it's the exact opposite. Secretion means giving off. Accretion means, like if I sucked my nose back in, you accreted the snot. Just every time you do that, you're accreting your snot back into your nose instead of secreting it out of your nose. Yay! So this is an accretion disk because it stole material from the other star and gathered it in. It's gathered it in. Yay! Now, here we go. This disk can give some problems to the white dwarf. There's two things that can happen because of this disk, okay? Check this out. Here we go. Here we go. We said it's made out of gas. But what elements is it probably most made out of? Here's a hint. I would like you guys to try to answer that. Here's a hint. This gas came from the outer parts of that star. Hydrogen, yes. Hydrogen is the number one thing. Helium is the number two thing. Almost every time, if you're just guessing, if you have no idea, a good guess on what it's made out of for things in space is hydrogen and helium, right? Now, here we go. Hydrogen is the number one thing with helium in this accretion disk. Okay, now, because of the gravity of the white dwarf, this disk is crushed tight. And if we crush it tight, its temperature will change. If you take a gas and crush it, what happens to its temperature? Does it go up or does it go down? It gets higher, right? It goes up, it gets higher. And what's the pressure going to be like? Well, the pressure is also going to be very high, right? Because of the gravity. and the density is going to be very, very high. Okay, so what might happen? Let's put our thinking caps on. You might have to have watched the last couple of videos to get this one. If this disk is made out of mostly hydrogen and we make it extremely dense and extremely hot, that means we're making it kind of like the center of the sun right now. So what could start to happen to some of that hydrogen in that situation? Yeah, fusion. Someone got it right off the bat. Fusion. Fusion could happen. So one of the things that could happen is that this disk could start to fuse. And that could be a problem because check it out. Where does the fusion usually happen in our sun right now? Where does the fusion usually happen in our sun right now? What part of the sun? In the core. That's correct. And that means that that fusion is contained by the weight of all of the rest of the sun. You can think of all the rest of the sun as like a protective shell holding that fusion in. Is anything holding the fusion in right here? Yes or no? The fusion's happening in this disk, so is there weight holding this fusion in? Nope. Nope, there isn't, right? And what that means, uncontained fusion is an explosion. It's an explosion. So if that disk starts to fuse, that disk will explode. It will explode, okay? And what that's called is, there we go. It's called a nova. It's called a nova. Let me reboot. Here we go. If the disk explodes, it's called a nova. Sometimes that's called a dwarf nova. I'll put parentheses around dwarf. But if you see nova by itself, it means a disk exploding in this situation. Oh, so somebody's mentioning supernova. This would be smaller than a supernova, like you learned about in the last couple of videos. It's not called a supernova because no stars are exploding. In order to be called a supernova, it needs to be an actual star exploding. And what's the only thing exploding here? It's just the disk. And it's going to be like millions and millions and millions and millions of atom bombs going off all at once, okay? That's crazy, right? But that is not enough energy, not enough explosive power to damage this star or the white dwarf. The white dwarf especially is super dense and resilient, right? So that dwarf nova just blows the disk off. But then the white dwarf can just make a new disk. So what could happen? What could happen over time if the white dwarf makes another disk? Yeah. If the white dwarf makes another disk, what could happen eventually? More explosions. So a dwarf nova can happen over and over and over again. I think I have a picture from the book of one of these. Here's a photograph of a dwarf nova from the Hubble Space Telescope. It's not the best picture, but that's the explosion happening right there, okay? And again, this can happen over and over and over and over again. Like a cycle, yeah.